Welcome to the thunderous heart of the steel industry, where scrap becomes the skeleton of cities. The process begins in the chaos of the scrapyard, a graveyard of old cars and forgotten machinery. A massive industrial magnet, powered by thousands of watts, selectively harvests the iron. Each load is a heavy mixture of steel alloys, ready for a second life. Tons of metal are dropped into the charging basket, the first step in this epic transformation. Inside the melt shop, the scale of production is measured in hundreds of tons per hour. The electric arc furnace roof swings open, exposing a core that burns brighter than the sun. A deafening crash echoes through the hall as the scrap is fed into the furnace's belly. This is the charge, the raw energy needed to fuel our modern infrastructure. With the roof sealed, the furnace becomes a pressurized vault of extreme heat. Behold, the electrode's massive carbon cylinders that will carry the power of a small city. They descend with precision, seeking the metal below to complete the circuit. The strike, a brilliant blue arc of electricity jumps, reaching temperatures over 3,000 degrees. This electrical storm melts solid steel in minutes, a triumph of human engineering. The ground shakes as the furnace pulls massive current to sustain the melting pool. Solid iron turns into a roiling liquid sea of orange light. Chemical energy from oxygen burners accelerates the process, cutting through the scrap like a knife. At the heart of the furnace, the steel is now a violent bubbling liquid at 1,600 degrees Celsius. Impurities, or slag, are tilted out of the back, leaving behind the purified molten iron. Now, the tapping begins. The furnace tilts forward to release its liquid gold. A 150-ton waterfall of molten steel rushes into the ladle, illuminating the entire factory. A storm of sparks fills the air, the signature of a successful heat. But melting is only half the battle. The steel now travels to the refining station. Here, the liquid steel is treated like a fine chemical recipe. The ladle furnace roof descends, trapping the heat for the final adjustments. Precision electrodes maintain the temperature while the final ingredients are prepared. Ferroalloys are shot into the melt, adding the strength and flexibility needed for rebar. Manganese and silicon dissolve instantly, re-engineering the steel at a molecular level. The oxygen lance is lowered, an aggressive tool used to burn away excess carbon. High-pressure oxygen creates a violent reaction, purifying the steel to exact standards. In this state, the steel's carbon content is lowered until it reaches the perfect balance. The final layer of waste, or slag, is raked away by a powerful mechanical arm. This glowing residue is removed, leaving a mirror-like surface on the molten metal. From the bottom, argon gas is injected to stir the giant ladle. The steel boils gently, ensuring every inch of the 150-ton load is chemically identical. A robotic probe takes a final temperature and chemical reading from the white-hot core. Success! The digital readout confirms the steel meets international construction codes. A small sample is sent to the lab via pneumatic tube for a final high-tech check. Spectrometers confirm the purity. The chemistry of strength is now locked in. The green light flashes. This heat of steel is officially ready for casting. The main crane lifts the ladle, carrying it high over the production floor. It moves toward the continuous caster, the machine that will turn liquid into solid. The slide gate valve at the bottom is the only thing holding back 150 tons of liquid fire. The ladle is positioned over the tundish, a critical distributor for the casting lines. The valve opens and a steady, controlled stream of steel begins its descent. The tundish fills, acting as a buffer to keep the casting process continuous and smooth. Steel flows into water-cooled copper molds, the birthplace of the solid billet. Inside the mold, the outer skin of the steel solidifies instantly while the core stays liquid. The mold vibrates rapidly. Oscillation prevents the red-hot skin from sticking to the copper. Water sprays blast the emerging strand, turning the red-hot metal into a solid structure. Guided by rollers, the steel curves from vertical to horizontal in a graceful arc. Multiple strands emerge at once, a mesmerizing display of mass production power. The strands straighten out, moving through the cooling zone at a steady pace. What was once liquid scrap is now a solid square of steel, known as a billet. The automated torch cutter moves into position, tracking the speed of the strand. A spray of sparks erupts as the torch cuts the steel into 12-meter lengths. The billets are now independent units, moving toward the massive cooling bed. Laid out to cool, they look like glowing orange matchsticks against the dark floor. As they lose heat, they change color, signaling they are ready for storage or rolling. A walking beam conveyor moves the billets with rhythmic, mechanical precision. Each billet is stamped with a heat code, ensuring 100% traceability for safety. In the storage yard, thousands of billets wait to be transformed into their final shape. When the rolling mill is ready, a magnet crane picks up the cold billets to begin. They enter the reheating furnace, a tunnel of fire that brings them back to 1,200 degrees. High-temperature gas flames ensure the billet is soft enough to be shaped like clay. The billet emerges, glowing with a bright yellow intensity, ready for deformation. High-pressure water jets blast away scale, leaving a clean, hot surface for the rollers. The billet enters the roughing stand, the first of many crushing encounters. Massive rollers bite the steel, forcing it to become longer and thinner in an instant. The steel begins to move faster, traveling through the mill like a red-hot snake. Loopers and repeaters manage the tension, ensuring a flawless flow of metal. With every stand, the diameter shrinks and the speed of the steel increases. The rebar is now flying through the finishing mill at 50 kilometers per hour. This is the final stand, the one that gives rebar its unique personality. Specialized rollers press the characteristic ribs into the surface for maximum concrete grip. The finished rebar zooms across the runout table, a blur of gray and orange. The flying shear snaps shut, cutting the high-speed rebar into perfect 12-meter sections. The cut lengths slide onto the cooling bed, filling the room with a metallic clatter. They roll and align themselves, cooling slowly to maintain their internal strength. Listen to the clinking of the steel, the sound of the metal contracting as it cures. Thousands of bars rest here, the final product of a 12-minute industrial symphony. Once cool, the rebars are grouped and moved to the bundling station. The automated counter ensures every bundle has the exact number of bars required. Steel straps are wrapped around the bundle with massive mechanical force. The sealer snaps shut. The bundle is tight, secure, and ready for the world. Robotic arms stack the 2-ton bundles, preparing them for the journey ahead. From the factory floor to the construction site, these bars will support the future. A final quality tag is attached, a guarantee of strength from mass production marvels. Trucks and trains depart, carrying the skeleton of tomorrow's cities. From scrapyard to skyscraper, this is the epic journey of steel. Thanks for watching.